saw that by 9 o'clock all the students were here. It is really encouraging and well done for that to you students. Just for a clarification, IAGRG, that it was given in the biodata, it means Indian Association of General Relativity and Gravitation. And one IUCAA, IUCA, we call it in short, IUCA, it is Indian University Center for Astronomy and Astrophysics. Now, yeah, the title of the topic is Inspiring Discoveries. As in mathematics, what I do is I start with the number theory part, then we go to certain experiments, then there is there are two mathematical models given here, and I would be asking you to do some calculations on that so that we may get the right result. And then the recent developments in mathematics. This is the way I am planning my talk. And just like to know how many of you are in 11th standard, around approximately any idea? All, but I thought there are some in 12th also. 12th also is there. Because in my talk there is a slide where I'm talking about the derivative. So if you are 12th standard students, I suppose you will be able to understand, but if it is just past 10th, then you may not get that derivative. But anyway, I will try to help you as much as possible in that. Okay, what is the need of numbers first of all? Why do we need numbers? To count, okay. It all started with counting in earlier days. Just for the use of counting, we used to have numbers. So when you start counting, which is usually the first number that comes to your mind? Zero. No, when you don't count with zero, do you say, no, you start with 1. Yeah, that's true. So it was 1, 2, then that way it went on. And those set of numbers, 1, 2, 3, 4, 5, and so on, if you continue that, that set of numbers has got a particular name. Any idea? Natural numbers. They are natural numbers. We call them as natural numbers. So that was the beginning of the numbers, used for counting, starting with 1, 2, and so on. But later on, as the life went on, what happens is that, suppose you get an equation of the form, like that second line, x plus 1 is equal to 0. Now, if you want to solve that equation, the problem is the positive numbers will not help you to obtain the solution of such equations. X plus 1 is equal to 0, the solution is? Minus 1. So you need to have negative of the natural numbers. Natural numbers were all positive, and we need to have the negative of such natural numbers. So we need to introduce few more numbers to the system that is already known to us, natural numbers. So we introduce the negative of such numbers. So those set of numbers are known as integers. I have written it there. It is known as integers. So the integers means we have natural numbers, negative of them, including 0. Now there is an interesting part about 0. We'll come to that a bit later. Including 0. So we have natural numbers, negative of them, and 0. But again, as the things goes on, even that will not help us in solving the real life problem. As you see the next equation you have, 2x minus 5, that is equal to 0. Then integers will not help us. Integers will not give us any solution as far as that particular equation is concerned. Now you solve it, you take 2x equal to 5, then x is equal to 5 by 2. They are not at all integers. So we need to have a new number system. So again, adding to the already existing integers, you add fraction to that, fraction. Fraction means the numbers of the form p divided by q. We assume that q is not equal to 0. What happens if q is 0? It is undefined. It is undefined. When q is dividing the numbers with 0 is undefined. And we denote it with infinite. Infinite is the symbol you use when you cannot do that, continue with that calculation. So we have rational numbers coming into picture. We call them as rational numbers. So rational numbers include now all the three sets, that is natural numbers, integers, and the numbers of the form p divided by q. They are known as the rational numbers. But again, as you go ahead, what happens is that if the circumference of a circle is given to you, circumference of a circle is given to you, and you need to divide that with the diameter, that will be always a constant. You take any circle, I am not talking about the radius 1 or 2 or 3. You take any circle, divide it with the diameter, the circumference of that circle, divide with the diameter, and that is going to be a constant. Now it is a surprising thing, because if the circle is a bigger one or smaller one, that ratio is always a constant. And as you know, that is pi. Now pi is not a rational number. Now can you give me the value of pi? Now 3.14, I can write it as 314 divided by 100. Okay, 314 divided by 100. Now that form is rational, isn't it? It is of the form p divided by q. Now why do we say that then it is irrational? Yeah, that is correct. It is not the exact value. 3.14 is not the exact value. Even we take, instead of pi, you say 22 by 7. Now 22 by 7 is also not the exact value of pi. It is an approximate value of pi. Just for the calculation purpose, what we do is we assume, we take a nearby value, that is 22 by 7 or 3.14. So we also needed irrational numbers. So we have rational numbers and now irrational numbers. Here the difference is, irrational numbers is not a part of rational number. So for integers, the natural numbers, integers were a part of rational numbers, but irrational numbers are not a part of rational numbers. Now any other irrational number can you give? Pardon? E. What is the value of it? Yeah, approximate value is 2.71. Any other irrational number? Yeah, once you start root 2, then you can have infinitely n number of irrational numbers. Okay, so they are irrational numbers. Now the usual number system that we work with, we call it as the real number system, which includes rational and irrational numbers. Including those two number system, we create the new number system, which we call it as the real number system. That is the number system usually we work with. There is another one also, I think we may not need it, but just for the sake of explaining it, the next number system we call it as the complex number system, because suppose you have an equation of the form x square plus 1 is equal to 0. Then what happens is that x square is equal to minus 1, so x is equal to I said x square is equal to minus 1, so x is equal to square root of minus 1. Now this square root of minus 1 or even square root of minus numbers are not defined in real number system. Now you denote it with I and all, that is fine. But square root of negative numbers are not defined in real number system. So that's why we needed another number system, which we call it as the complex number system. But we keep it at that place only. We stop it with the real number system. Now you have infinite set of numbers, but all these numbers are denoted by just using 10 digits. Is that true? Yeah, we are using only 10 digits. That is from 0 to 9. So where did it come from? These numbers, where did it come from? Okay, there were other number systems, like we have Mesopotamia, that civilization, they had their own number system, Greek, Egyptian, then Roman. Among these, the popular one was the Roman number system. The reason can be their physical presence in all over the world. That can be the reason for their popularity. But have you ever come across any difficulty using Roman number system?
Yes, sir.
Yeah.
There is no zero in the Roman number system.
Okay, so you are saying 0 in which number system we have?
The one in which
They are already showed one, the previous one. Okay, 0 to 9. Okay. She is right. There is no 0 in the Roman number system. The question is why there was no 0 in the Roman number system. Anyway, we'll take up that question again. Now, other problem with the Roman number system is, you see that first calculation, that is 17 plus 13. How do you add it? I'm just talking in terms of those symbols. In Roman number system, you cannot add two numbers, you cannot subtract two numbers, forget about the division. Even if you cannot do plus and minus, then other things are not possible. And for the 10, we have the symbol X. Now, talking about that symbol, when you start with, if you want to mention 1, usually how do you mention 1? Usually, how do you mention 1? Or like this, you say 1. So this is the symbol for 1 in the Roman number system. Then for 2, 3, 4. But when you say 5, if you look at, you see that shape, V. It takes that V shape. That's why they use, instead of 5, we use that shape V. And in Roman number system, what happens is that if you put 1 on the left side of a symbol, you reduce that by 1. So you keep 5 and keep 1 on the left hand side, that stands for 4. Similarly, 1 on the right hand side, it stands for 6. And maybe this V and another V kept in the other direction gives you X. Now that can be the reason for 10. 2 5s together gives us 10. Fine. So in the Roman number system, we have X standing for 10, L for 50, C for 100, D for 500, M for 1000. Now, can you give me the number, the highest number, which can be written using Roman letters, not repeating more than once? Using all these symbols, can you give me the highest number, which can be written using these symbols, but without repeating? Just try it. What he said was 1566. I think it is 1666. You just try that. The value is 1666. Without repeating any symbol. That is, you can use once, but otherwise without repeating it. To the highest number possible in this number system is 1666. Now, if you want to mention 1 lakh, how do you do this? 100 times M. 100 times M. You need to write 100 times M to denote 1 lakh. Now see the problem with this number system. It was a popular one. It never had 0 with that. You could not do any calculation with that. Still, it was popular. Now, what we are going to talk about is the number system that we use. Actually, it is from India. Now, how it went to other countries and came back again to India. I will just talk about the history of it. But before that, it is interesting to read this sentence one by one famous Laplace, who said, "It is India that gave us the ingenious method of expressing all numbers by means of 10 symbols." That's those 10 symbols that we were talking about, 0 to 9. Each symbol receiving a value of position as well as an absolute value. As you know, we have in the decimal number system, there is a positional value as well as the absolute value of it. We shall appreciate this achievement when we remember that even it escaped the genius like Archimedes. Even they could not get this simple, very simple system. Now, it was by Laplace in the book Mathematics for the Million. Now,